Traditional keyword-based approaches to conducting literature review using tools such as Google Scholar may not provide the most relevant literature, especially if contributions are framed using different terminology in different papers. In this paper, we present vitaLITy, an open-source visualization approach for conducting literature searches. vitaLITy leverages the power of large language models to help users perform paper retrieval through a more accurate semantic understanding. The system uses a novel Retrieval Augmented Generation, or RAG architecture, as well as prompt chaining. Let me walk you through the interface. First, the paper collection view shows the entire corpus of more than 66,000 papers from 38 different visualization venues from 1970 to 2023. Users can search the paper collection based on different fields such as title, author, source, year of publication, and so on. Once we apply filters in the paper collection, the Metadata tab will display the meta information of the filtered papers. There are also 3 function buttons here. The first will plot the paper on the UMap visualization, allowing us to explore and select additional nearby points in the UMap to try to find semantically similar papers. The Info button will provide additional details on any of the selected papers. Next, the Select button will add the paper to the Similarity Search tab. We can search for similar papers based on one or more selected papers as the seed. Clicking Find Similar Papers will show the output in the Results tab. The larger the value in the similarity column, the more semantically relevant the document is determined to be. We can also search for relevant papers based on work-in-progress paper abstracts. Lastly, the Save button allows the user to save a paper that they're interested in, which will allow users to later on summarize or export the saved papers. Compared to the predecessor, vitaLITy, the vitaLITy system provides 3 key new features. The first new feature is the addition of an ADA embedding option provided by OpenAI. Once we select the ADA option, the similarity search will find similar papers from the ADA embedding space, and the UMap visualization will reflect the 2D point projection in the ADA embedding space. Next, we added new features using a large language model, GPT 3.5, to summarize, compare, and contrast papers in the saved paper view. While we provide some default prompts, users can customize the prompts that are used in the large language model according to their own needs. Finally, we added the Chat with Your Data view. This view allows users to ask natural language questions based on the paper corpus dataset. Next, I will demonstrate how you might use these new features through a usage scenario. Suppose you're a researcher in the field of geographical sciences. You decide to use vitaLITy to kickstart your literature review on geospatial visualization. You begin by navigating to the Chat with Your Data text area and enter, "Can you find me some papers that combine geographical science and data visualization?" vitaLITy responds accordingly. In the response, the system highlights in blue the title of the papers that are cited in the answer. Clicking on the title will display the details of the paper. Likewise, you can add the article as a seed paper to a similarity search, display it in the UMap, or save it. After you added this paper as a seed to the similarity search, you decide to use the ADA embedding to see if you can find more relevant papers. The search results are displayed in the Output tab. You skim the abstracts of the results and decide to select the top few papers that have a high similarity score and save them. Next, you navigate to the saved paper list and use vitaLITy to review the papers you just saved. By clicking on the Literature Review button, vitaLITy will produce a brief summary of each paper, as well as compare and contrast the results. Finally, you can export the entire set of saved papers in .bib format. While recent research shows that it doesn't happen often, the output of the large language model can sometimes hallucinate, so we encourage users to validate the output accordingly. Likewise, please seek guidance for your relevant publication venue on acceptable use and reporting of the use of large language models in academic writing. Thank you for watching our video. For more details on the novel architecture or additional usage scenarios, please read our paper.